What can volume data tell you about your lungs?
In this video, we're going to look at how Pasco's wireless spirometer helps students learn about lung function. A spirometer test shows lung volume patterns that help assess lung function. A spirometer is a device that measures pressure changes and determines the air volume moved in and out of the lungs while breathing. Pasco's wireless spirometer comes with a USB charging cable, 3 mouthpieces, and 3 filters. To assemble the spirometer, line up the prongs on the key in the mouthpiece with the holes in the spirometer. Find the tapered end of the mouthpiece and slide the filter onto it. If the filter does not seem secure, try fitting the opposite side. The mouthpiece and filter are disposable and are meant for use with only one individual over a day or 2 of testing. Replacement mouthpieces and filters can be ordered from Pasco.com. Once assembled, work in pairs so one person is the test subject and the other is in charge of data collection. I will be the test subject.
And I will collect data. The test subject should be relaxed and can either stand or sit. They cannot look at the data while it's being recorded, so the lab partner can coach them through breathing cycles while collecting data. The test subject must remain as still as possible during the entire test. Before starting the test, the data collector should walk the subject through the procedure. Let's demonstrate. You can only breathe through your mouth during the test, so you have to pinch your nose closed with one hand and hold the spirometer handle in the other hand. Hold it upright and straight. As soon as the filter goes in your mouth, you will hold your breath until I tell you to start breathing. Place the filter in your mouth as far as possible with your lips forming a tight seal on the outside of the tube. Inside your mouth, it's okay to gently bite the tube, and your tongue can rest under the bottom of the filter tube up against your bottom teeth. Keep holding your breath and stay perfectly still. For now, take the filter out. So now we can practice with the breath cycles, but during the real test, that filter stays in your mouth the whole time. Here's how the breathing will go. Each breath is an inhalation followed by an exhalation. So let's practice that. Take 4 normal breaths. 1, 2, 3, 4, maximum inhale, followed by forceful exhale. And now 2 normal breaths. 1, 2. Okay, ready for the real test? Pinch your nose, hold your breath, and position the filter, stay still. I'm collecting data, but we have to wait for the Bluetooth connection light to finish flashing red and green to return to steady to show the sensors calibrated and ready. Now take 4 normal breaths. 1, 2, 3, 4. Maximum inhale, maximum exhale, 2 normal breaths. 1, 2. And now I've stopped collecting data and we're done. And I know it doesn't exactly feel natural to breathe through that filter, so you might want to go through several runs, but your results will look similar to this. It's okay if the 2 recovery breaths at the end here look like this. They're slightly offset compared to the initial breaths. In any case, avoid using those recovery breaths for analysis. This is a lung volume versus time data display, so the upswings represent inhalation and downswings represent exhalation. The coordinates and delta tools will be especially handy for analysis when looking for volumes and capacities, such as the normal breath volume, which we call tidal volume, or the forced vital capacity and forced expiratory capacity in 1 second, which are important for assessing lung function in clinical settings.
You can check out the investigation titled Spirometry, Pulmonary Function in Pasco's experiment library to learn how to interpret each of the regions of a spirometry test and other ways to display spirometry data. One final note, please remember that this sensor is designed for educational use only. It's not a medical device and should not be used with any apparatus involved with life support, medical testing, patient diagnosis, or industrial control or testing systems. Thanks for watching. We'll see you next time.